Welcome back. Um, this particular video, the next video, I'm going to actually walk you through the mechanism because somewhere down the road I might test you. I might give you the mechanism in a different ways as multiple choices and have you pick the correct choice. So this video and the next video, I am going to actually walk you through the mechanism because I think it's kind of important to know this because this is kind of foundational for a few other things down the course. All right, so I am both these videos I'm going to express the mechanism with respect to a ketone, which is this, because there's no hydrogens on either side. If there is hydrogens, I will show you there's hydrogens. The mechanism is exactly the same for an aldehyde. Okay, so I'm going to show you two mechanisms. Both are with respect to a ketone, but the mechanism is the same with respect to an aldehyde as well. The products will be different. The mechanism itself is the same. Okay. The first is, what if you carry out the reaction in a basic medium? Okay. As indicated by a negative charge. Okay. OH minus. Okay. This is basic. Okay. Typically, negative charge is basic. Positive charge is acidic. Okay. What if you carry out a nucleophilic addition reaction on a ketone or an aldehyde in a basic medium? Okay. And the simplest base is water, and you make it more basic, then you get OH minus. Okay. If you don't know how I got that, well, this again is general chemistry 170 or 175. You may have seen it both occasions. H2O plus H2O. This is the classic KW. Do you remember that? Okay. Well, that's what it is. So you remember KW equals H3O plus times OH minus equals 1.0 e to the negative 14. Remember that? Okay. Anyways, here we're focusing on the OH minus, which is the basic, and the H3O plus, which is acidic, will be in the next video. Okay. So this is very important because whenever you have OH minus, it always attacks the carbonyl with the O, which is the carbonyl carbon. Okay. So the OH minus here, this is the mechanism. It attacks this. Okay. And then because it comes with a negative charge, the negative charge has to be distributed to another element, which is, again, in this case, is the O. So let's draw everything the way it's supposed to. Okay, and I'm going to get my different color. So this is your OH, which is attached itself here. And because the OH came with the negative and I attached itself to the carbon containing the double bond O, we move the double bond to the O, and now so the O will get the negative charge. Somewhere down the road, the charge has to be distributed. What it came with must be somewhere. I think we've looked at another mechanism earlier where we did that. Now this reacts with the water that's present in the bottom portion. I explained it to you how reactions work when you have two reagents, one on the top, one on the bottom. I explained it to you earlier. So the O minus comes with the hydrogen, and then this comes back here. So you will end up with, this is the product. What is important to note is you're ending up with what is called a diol. Okay, I'm going to write it. So whenever you react a ketone or an aldehyde, okay, with a base such as OH minus, you are going to end up with a diol. Okay, I don't want to write the whole name, but we got two OH groups. So whenever an aldehyde reacts with the base, or a ketone reacts with the base OH minus in a basic medium, you produce a diol. That is, you end up with two OH groups on the carbon. So essentially what we have done here is we have taken the carbon containing the double bond O and converted it to You leave everything the same. You have a OH on the top, you have a OH on the bottom. So the change is occurred here. Okay, that's what we have done. Now this exact mechanism, say instead of what you started with, which is a ketone here, let's say I have this. Okay. If this was my this is an aldehyde, and if this were to have reacted with OH minus and H2O, it would have caused very similar product. The only difference is instead of this metal that was in the earlier reactant, you will just have hydrogens. Okay, but you'd still have two OH groups, so you will still have a diol product. But again, your product would look different, but you still have two OH groups on this carbon containing the double bond O. All right, so that's basic. Let's see what happens in the acidic medium. See if we get something different or we still get the diol as the product. Stay tuned.